Guys, let's take a look at the skills and concepts that you need for our math class. This is grade 11 university math, 3U as we call it. I'll be calling it that quite a bit. So this is the first package I handed out, and we'll take a look at some of the skills. So first up here, let's look at the simplifying of expressions review. These are the answers right here. So this should be on the Google Classroom for you to access if you don't have this. And we did this in class, or we're planning on doing it in class. So when you have an expression like this, notice that there is a sign here between the terms. So here down below there isn't in C, but for A there is, which means that we are going to expand this, and then collect like terms. So you go 3 times x is 3x. So this is distributive property. If you see a bracket, whenever you see a bracket, you multiply everything in the bracket by what's outside the bracket. In this case, it's a 3 outside the bracket, or a plus 3. We don't write the plus, but we will notice how it's different than the minus that we're going to run into in a bit. So 3 times x is 3x, 3 times y is 3y, so that's how you get these two terms. Then you'll expand this bracket, or open up this bracket, and you multiply everything in the bracket by what's outside. Now, be careful. There's a negative associated with the 5 here. So it's negative 5. So minus 5 times x is minus 5x, and minus 5 times minus 7 will get you 35 as your number, but a negative times a negative will get you a positive, so you get plus 35. Now, collect like terms. You look around and you say, are there any terms that are similar that I can collect? This is 3x. Is there another term like 3x? Yes, there is. There's minus 5x over here. And when you collect those, you have 3, you have minus 5, you have negative 2, or minus 2 of those. The 3y and the constant here, the plus 35, are not like terms to anything, so we just write them out. Now notice we write the equal sign on each step, and we keep it nice and aligned here to keep it nice and clean. Almost exact same thing in B. The difference with B is that you have fractions. Not a big deal. Just get used to multiplying with fractions. Most of the time, if you get asked this, can you use a decimal? The answer is sometimes. In this case, you could actually, because the fractions terminate. So you have 1/2 and 3/2. They are 0.5 and 1.5. You can't use a decimal if you have a fraction that doesn't terminate. So 1/3 is 0.3 repeating. So you can't use that as a decimal. But I'm going to use the fraction here. Don't be afraid of fractions. 1/2 times x squared is 1/2 x squared. 1/2 times 1 is 1/2. Again, there's a negative here. So you're multiplying negative 3/2 times x squared to get negative 3/2 x squared. And then negative 3/2, or negative 3/2, yes, sorry, times negative 1 is plus 3/2. Now, like terms, you have an x squared term here, an x squared term here, minus 3/2 plus 1/2 gets you negative 1x squared. So there's plus 1/2 minus 3/2. So as a decimal, you can use your calculator for this too, but as a decimal, it will be this. That's how many x squared you have. Then you have 1/2 and you have 3/2. When you add fractions, the other thing you can do is when you add fractions, remember, you leave the denominators the same. So this will be over 2. How many halves do you have? You have 1, you have 3, they add up to 4. 4/2 is 2. That's how you get this answer. So 4/2 is correct, but we want to keep things simplified as possible. So this is left there, changed there too. Here, a little different. So in this guy here, what you're going to do is FOIL, because there is no. So I'm looking at C now. There is no plus or minus between the brackets. So over here in A and B, and even in D, you see that there is a negative here. So that means find out what this is and add it or subtract it to whatever this is. In this case, there is no plus or minus between, so you're going to multiply this out. And because it's binomials, 2 binomials, we use the old FOIL method. First outside, inside's last. So you're going to multiply it like that. When you do so, you end up with this big mess. And not really mess, but you have that 4x times 4x is 16x squared. And then you keep moving your way through. And these two terms here are like terms. You collect them and they negate each other. You have 4xy minus 4xy, 0xy. You may have looked at this right away and said this is a difference of squares. And you would be correct. So I don't want to jump around too far, but if you notice that, that's great. This is minus y squared. Here you'll expand this. 4x times x is 4x squared, and then 8x, and then again with a negative. All examples, we're using negatives here. Beating a dead horse, which is an aggressive term if you think about it, but that's what happens. And the like terms are x squareds. There are 4 and minus 2, so 2 of them, 8, and 8 is 16, and you're all done. Now, don't do anything special with this. Don't go, this equals anything. You have x squareds, you have x's, they're different things, okay? So x squareds are different than x's, are different than xy's, are different than x cubes. If you're going to collect like terms, the variables have to be identical, okay? The only difference would be if you had something like xy, like 1xy plus 1yx. These are the same things because they're just written in a different order, okay? xy is the same as yx. That's why we write things in alphabetical orders to not get confused. But for example, if you had 3x squared y plus 2xy squared, these are not the same thing, okay? Because you have x squared, y, and xy squared. You want the exact same variables, the exact same exponents. So I have an x squared and a y, I have an x and a y squared, not the same thing. If I had this, x squared y, x squared, y squared, not the same thing. Okay, similar but not the same, so you can't collect any further. You'd be shocked at how many people keep going. Evaluating expressions, all you're going to do, excuse me, all you're going to do in any of these is you're going to sub in to the equations above. Where did we do this though? So here at the very end here, okay, once you have the minus 2x plus 3y plus 35, everywhere you see an x, put a 3. Everywhere you see a y, put a negative 5. So when we do that, there's not much tricky here. Just negative 2 times 3 is negative 6. Just be careful with your signs, right? You can put this straight into calculator, or you can expand it like this. Whatever you're doing, if you get 14, good for you. If not, just check to see. It's probably a sign issue, okay? But this is 2 times 3 plus 3 times negative 5 plus 35. This one here, a little bit careful. You have minus x squared, so the minus is not on the x, it's in front of it, so you're going to square it and then put a negative. That is different than this, okay? So that would be negative 3 all squared. Okay, so be careful with that one. The negative is not in a bracket, which means it's the negative of x squared. So find out what x squared is, and then make it negative. Okay, so that one there is a little tricky. Same thing here, okay? You're not going to, so especially in this one here, you're going to square the negative 5 and then make it negative, because over here it's minus y squared. So minus y squared, y is negative 5, square it, and then take the negative. So that one's a bit tricky, but hopefully you got that one. And the collect like terms, same sort of thing with d. No, in d we only have x's. So x squared and then x. And that's it for the first part here. Except you want to, sorry, we have number 3, sorry. And then I think I'll cut the video after this, and then we'll make another video for the rest of it. Here we're going to solve the equation. So notice equation equal sign are needed for an equation. So 5 times something minus 8 is equal to 7. So what is that something? What's the x? And what we do is we, you've done this many, many times. What you do is you isolate the variable, and to do that, I like to think of getting rid of everything that's bugging the x here. So you start furthest away, you have a negative 8. What's that doing to the x? It's subtracting, so you get rid of it by doing the opposite. You add it, and then the 5 is multiplying, so you get rid of it by dividing, and then you end up with x equals 3. You can always sub back in to see if you're correct. So 5 times 3 minus 8 is 15, minus 8, which is 7, and that is one of these left side, right side checks. Right, because you had 7 on this side, and you draw your happy face, oops, and etc. Same with this, not same with this, but here you're going to solve, let's actually, yeah, let's do B, I guess. We'll go in order. You are going to, what's going on here? Sorry. There we go. You are going to simplify first. So you have 5, 6y minus 3/4 y. So you have a bunch of y's and you have a bunch more y's and you have to put them together. To do that, you need a common denominator. So over here, looking over here, this is what would happen to get the 1/12. 5 6 minus 3/4. 5 6 is 10/12. Minus 3/4 is minus 9/12. Y 12s. 6 and 4 both go into 12. You could also use 24ths. If you didn't see that they both go into 12s, you could use 24ths and you get 20. The reason I say you can use 24ths is you can always multiply the denominators to get a common denominator. So you go 6 times 4 is 24. Then you get 20 24ths, subtract 18 24ths, and you end up with 2 24ths that you would reduce to 1/12. So either way, you're going to get 1/12. 1/12 y equals -3. That's the same. So to get rid of a fraction, it's the same as y over 12. So 1/12 y. To get rid of that, you'd multiply each side by 12. Another way to look at it is to say that 1/12 y is y over 12 is equal to -3. You can do it like that, and then you're going to multiply to get rid of the 12. And when you do that, remember that this is -3. Keep that negative. Here, you'll expand first. Okay, so that's what happens here. Boom, boom, boop, boop, and you get up with that. And this one's a little different because we have variables on both sides. We have constants on both sides. So what you want to do is move the variables to one side. If you plan ahead a bit, you could say, let's have the positive variables on the left. It doesn't really matter if you want the variables on the left or right. People like the variables first. So if you're going to do that, you have the -2x here. You have to bring over the 4x, the -4x. And when you do that, it becomes plus 4x. Here you have plus 6. And then you bring that over, it'll be -6. And then you end up with this on the left and this on the right. Collect like terms, 2x minus 4. And then divide by 2 to get -2. A little more work on this one here. If you have fractions on both sides, this one's about as hard as it gets. First thing you'll do is get rid of them by cross multiply. Okay, so you can multiply here by 3 and then multiply this by 4. Expand. Boop, 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 boop. Okay, give you a second look at that. And then move the 8 on this side, move the -6 on this side. And when you do that, you end up with -5x and then 10. Divide by -5 because the -5 is multiplying the x, and then you end up with -2. Okay, that's a tough one. So if you have fractions, that's what you do. You cross multiply. You could also multiply both sides by, it's the same story as multiplying both sides by 12. I don't like that really. Just think of this. Whenever you want to get rid of a fraction, you can move a fraction across a equal sign by multiplying it on the other side. So you have 3 on the bottom of the fraction here. And when you bring it across, you do that. So for example, if I had 1/2 equals 3/6, what I can do is bring this 2 over here and get rid of it. And then I have 1 equals 3 times 2 is 6 over 6, which is 1, right? So all day long, you can just bring things across an equal sign as long as you do the opposite operation. So if it's on the bottom of a fraction, that's a division. When you bring it across, it multiplies. Okay, so that's almost, I'm almost out of time. I get 15 minutes for free, and I'm too cheap to pay for more. No, 15 minutes is long enough for a video, and I will do the next thing in the next video. All right, see you soon.